Alright, so, guys, yesterday we talked about solving absolute value equations. The day before, we talked about solving inequalities, right? Today we're putting them together. We're doing them both. So, if I asked you to solve the absolute value of x is less than 3, you end up getting a graph that looks something like this. Well, let's think about that. What values for x would work in the absolute value of x is less than 3?
-3.
-3 wouldn't actually work because, let's look at it. The absolute value of -3 is 3. That's not less than. There's no or equal to. So we're close. But 2 would work. Right? I plug 2 in here. Absolute value of 2 is 2, which is less than 3. What else would work? 1. 1 would work. Absolute value of 1 is 1, which is less than 3. Anything between -3 and 3 would satisfy that equation. Well, if you look at this graph, we've seen a graph that looks like this before, haven't we? Yeah, what type of graph is that? An AND graph, right? We did that, what day is that? Day 1, right?
Yes.
Day 1. So what's going to happen, guys? If you have an absolute value equation, or absolute value inequality, and it is a less than symbol, our connecting word is going to be AND. So if it is less than, we think AND, or the easy way to remember it is LAND. If it is a less than problem, to be able to solve it, we're going to turn it into an AND statement, or an AND problem with the inequality, so we can solve it. Alright, so that's the first fill in the blank. If it is less than, the connecting word is AND. So an example would be the absolute value of 3x minus 5 is less than or equal to 16. If I want to solve that for x, solve that inequality, I need to turn this into an AND statement so my absolute values go away. The way that I do that is I keep this whole part and just drop the absolute values. I add the same sign behind it and I turn 16 negative. Right? And it turns into a compound inequality. Right? A compound inequality tells me I have an AND statement. You could also write it out as two separate inequalities and have the word AND in between them. You could write it out as 3x minus 5 is less than or equal to 16. And -16 is less than or equal to 3x minus 5. Or you could have them flipped around and you have 3x minus 5 greater than or equal to -16. Either way works. I'm going to do the compound inequality. That's the way I prefer to do it. I think it's the easiest way to do it. And then when we ask you to graph it later on too, it's going to make it easier. Okay? So once you've changed it to an AND statement or a compound inequality or the two separate inequalities with the AND in between them, you get rid of your absolute value, now you can solve it. How do I solve a compound inequality like this? Add 5 to all of our sides. I get -11, less than or equal to 3x, less than or equal to 21. Then what would I do?
Divide by 3.
Divide by 3 everywhere. -11 thirds, less than or equal to x, less than or equal to 7. Yes, -11 thirds is -3.66 repeated. You could reuse that. I prefer if you use the fractions, but the decimals with the repeated sign are okay. And that's our answer. Now, this problem didn't ask us to graph that, but there will be problems when we do them that will ask us to graph it as well. Alright? So less than will turn into an AND statement. You need to make it a compound inequality before you can solve it. So remember, we can't take stuff out of those absolute value signs. So we got to get rid of them. Alright? So if less than turns into AND, what do you think greater than is going to turn into? Or. So we can see that by looking at a graph for one of them. The absolute value of x is greater than 3. Well, what numbers would work for x in that case?
4.
4, right? The absolute value of 4 is greater than 3, so that equals 4. Perfect. What other numbers would work? 5, 6, 7, 8. Are there any negative numbers that work? That would fit in there?
No.
Yeah, which one's Baker?
The ones that are bigger than 3. Or
Go.
like the negative numbers.
The ones that are like smaller than -3, right? It's like -4. The absolute value of -4 is 4. It's greater than 3. The absolute value of -5 is 5. It's greater than 3. So anything to the left of -3, anything to the right of 3. What kind of graph does that look like? Or. So a greater than statement with the absolute value is going to turn into an or statement. So your connecting word when it's greater than is or. In other words, we call that GOR. G-O-R. Right? Land and GOR. Less than turns into and. Greater than turns into or. This is only when we have absolute value signs, guys. I know we solved inequalities the other day. If you don't have absolute value signs, solve them normally. We need to get rid of the absolute values so we can solve them. So we need to change into these type of statements. So if I have the absolute value of 3x minus 5 is greater than 16, I'm going to change it to an or statement. By, this stays the same, I just drop the absolute values. Or, I keep the same sign but on the other side, and I make it -16. If you want, you could also do 3x minus 5 is greater than 16, or 3x minus 5, and switch the sign and make it -16. This means the exact same as this. I like writing it this way though because I get to keep the same sign. The sign doesn't change. I switch it to the other side and I make it -16 instead of +16. And then I'm just solving them like normal. I'm adding 5 to both sides. I get -11 is greater than 3x. And I divide by 3. -11 thirds is greater than x. Or, add 5. 3x is greater than 21. Divide by 3. X is greater than 7. Now, I'm going to rewrite this for graphing purposes later on. I would write it as x is less than -11 thirds. Just that's how my OCD brain works. I like to have x on the left side. If you wrote it the first way, that's perfectly fine as well. This is a perfectly okay answer. Now, I'm going to write it like this, but you can leave it like that. That's fine. It will not get marked wrong if you leave it like that. Does that make sense? Do we have any questions so far? Less than turns into what type of problem with an absolute value in it? And. Greater than turns into what type of problem with an absolute value in it? Or. Less than and greater than or. Yes, Baker?
Like, how do you know when you use this strategy versus the one you used yesterday?
When there's absolute values inside of our inequality. So like if you did the one yesterday, was it yesterday? No, it was 2 days ago. Okay, so the one yesterday was with an equation. We had an equal sign.
Oh.
So these ones we have inequalities, less than, greater than. Okay? Good question. Very good question. Alright. So let's try some more examples. Let's try and graph them. Solve them, then graph them. Before you can decide if it's less than or greater than, and or, the absolute value has to be by itself. Because if you're solving that absolute value by itself and you multiply or divide by a negative, what happens to your sign?
Flips.
It flips. So get your absolute value by itself first, then decide what type of problem we're going to have here. Alright? Oh, a reassessment? I do.
You can take it now, sorry.
Yeah, I told her she could. Alright guys, hey, is that first absolute value, is it by itself? In the first problem, we have absolute value of m minus 2. Is that by itself?
Yeah.
Yeah, so we can change it. What type of statement do we have? Less than or greater than? Less than. So we're going to change it to an and problem. So let's do that. I don't have them circled on here. This is the reassessment. And make sure it is. Thank you. Alright, so let's change it. To change it, I have m minus 2 is less than 8. Same sign on the other side. And it makes a -8. Right? An and statement turns into a compound inequality. Sorry for the interruption there. Now that my absolute values are right, guys, when you change it to the and the or statements, the absolute values go away. Right? That's why we do it. Now we can solve. Alyssa, what should I do to solve?
Add 2.
Add 2. Good. Add 2 to all the sides. Negative 6 less than m less than 10. Now I gotta graph it. Who thinks they can know how to graph this? Anyone? No one else? I guess I'll just pick on somebody then. Oh, Sim. Awesome. Thank you for volunteering.
Just put an open circle at 10, and put an open circle at negative 6, and then don't you put since it's, but yeah, don't you, yeah.
It's an and statement we shade in between, right?
Yeah, that,
Good. So hey, Sim, why did you say open circles?
because it doesn't have a line under the less than sign.
Doesn't have a line underneath it. Doesn't. It's not or equal to. So it's an open circle. Remember, on our graph, it's an open circle. It's an and statement. I shade in between. Good. All right. Second one. Absolute value of x plus 5 is greater than or equal to 11. Is the absolute value by itself right now?
Yes. Or no.
No. Yes. No, it's not. So let's get it by itself. How do I do that?
-5.
-5. So -5 from both sides. We get absolute value of x is greater than or equal to 6. Okay. Greater than problem turns into what type of statement? Or. So GOR, right? So I get x is greater than or equal to 6, or I keep the same sign and make it negative 6 on the left. Well, right? I change an or statement. This one stays the same. Take x over here. I keep the same sign, but it makes it negative 6 on the left. That makes my or statement. Is there any solving I need to do in this problem?
No.
No. So I'm just going to change this around, because like I said, I kind of OCD about that. X is less than or equal to negative 6, or x is greater than or equal to 6. If you leave it like this, that's perfectly fine. I will not mark it wrong. Okay? So I need to graph that now. Cam, how am I going to graph that?
Put a circle at -6, colored in.
Circle at negative 6 colored in.
And then a circle at 6, colored in.
Okay, and which way am I shading?
6 going to the right, -6 going to the left.
Good. I'm greater than 6, so I go to the right. I'm less than negative 6, so I go to the left. Hey guys, any questions on that? Alright, we got 2 more problems to do, and then we're done. We gotta go quick, so we're kind of running out of time. It's a Wednesday. I forgot again. It's cleared. Alright, you guys have 53, don't you? Okay. First one, 9 times the absolute value of r minus 2 minus 10 is less than 53. Is the absolute value by itself? No, so I need to get it by itself first and foremost. So I'm going to add 10 to both sides.
Then divide by 9.
9 times the absolute value of r minus 2 is less than 63.
Divide by 9, 7.
Good, Cam. Divide by 9. Absolute value of r minus 2 is less than 7. Alright, the absolute value is all by itself now, correct?
Yep, add 2.
Yeah.
Okay, so what type of statement is it?
It's an and.
It is an and, because it's a less than, right? Land. So it's going to turn into an and statement at this point, so I can solve. So I can't do anything until I get rid of those absolute values. I'm going to go below here. So I'm going to get r minus 2 is less than 7. It stays the same here, just got rid of the absolute value. Sign goes to the left side, and it's negative 7 over here. Right, that makes my and statement. So Jackson, how would I solve that and statement, that compound inequality?
-2 or +2.
Plus 2, right? So we're minusing 2. Good. Negative 5 less than r less than 9. So I've solved the inequality. Now I need to graph it.
Do you need help?
I do need some help. I'm struggling here.
Okay, so put an open circle at -5, or open one at 9, and then since it's an and, you put them together.
Good. Shade in between with the and statement. Open circle at -5, open circle at 9, shade in between. Very good. Alright, let's sprint through the last one quick, and I gotta hand out the homework before the bell rings. Okay. 9 times absolute value of 3n minus 2 plus 6 is greater than 51.
Minus 6.
Got a minus 6 and divide by 9, so I get the absolute value by itself. So I got 9 times the absolute value of 3n minus 2
5.
is greater than 45, and I divide by 9. The absolute value of 3n minus 2 is greater than 5. So the absolute value is by itself. It is a greater than problem.
4.
It turns into an OR. So I get 3n minus 2 is greater than 5, or negative 5 is greater than 3n minus 2. Right, just setting it up and then solve it. Add 2 to both sides. Negative 3 is greater than 3n. Divide by 3.
1. -1.
Negative 1 is greater than n. Or, add 2 to both sides. 3n is greater than 7. Divide by 3.
7.
N is greater than 7/3. Right, I'm going to flip this one around again. So, the OR statement. I have an open circle at negative 1. Shade to the left, because it's less than. Open circle at 7/3, which is 2 1/3. Shade to the right. I know I sprinted through that one, I'm sorry. But I want to get through it and I need to be able to hand the homework out. So, first things first, guys, get that absolute value by itself. You're left with the greater than symbol. Makes it an OR statement. Drop the absolute value with this one. Take the sign, move to the other side, and have negative 5 on the left. Then solve it. Yes, Sim?
Why do you put the 7 there closer to the 2?
Why did I put the what?
Why do you put it closer to the 2?
Because it's 2 1/3. Right?
Oh, because that's how many, okay.
Yep. Alright.
That's how many times.
Subscribe. Swipe up.